and gentlemen, a very good evening to you all. As some wise soul once said, and I quote, "Gaining knowledge is the first step to wisdom. Sharing it is the first step to humanity." This is the philosophy that guides the Aeronautical Society of India as it spearheads aerospace activities among the scientific and engineering communities, students, and the general public. Through its various lectures, workshops, seminars, and outreach programs, the AESI continues to motivate young minds and inspire society. We are here today to take part in the 21st edition of the acclaimed annual event, Dr. Srinivasan Memorial Lecture, organized by the Aeronautical Society of India, Thiruvananthapuram chapter, in association with Vikram Sarabhai Space Center. Dr. S. Srinivasan, an exceptional scientist and an architect of Indian rocketry, was truly a visionary. He helmed the Vikram Sarabhai Space Center from 1994 to 1999. He was widely known for his techno-managerial skills and contributed significantly to taking the organization to greater heights. As a tribute to this exemplary leader, and as an effort to carry on his legacy, the Aeronautical Society of India conducts a special lecture each year on cutting-edge and futuristic issues delivered by an esteemed personality in this field. For this year's edition of Dr. Srinivasan Memorial Lecture, we are honored to have with us Dr. Satish Reddy, Chairman DRDO and Secretary, Department of Defense R&D, Government of India. He will be delivering a lecture on the topic of the hour, Aeronautical Ecosystem in India. Before we begin, I request the dignitaries, Shri S. Somnath, Director VSSC, and Dr. Sam Dayal Dev, Director IISU and Chairman AESI Trivandrum Chapter, to kindly pay homage in the form of floral tributes to Dr. Srinivasan. Thank you, sirs. As we set out in the pursuit of knowledge, let us invoke the blessings of the Almighty. I now request Shri Arun Raj to render the invocation.
Kshanam pratikshanam yannavam navam tacha sundaram yaccha tachivam varshanutanam te shubham mudam uttarottaram bhavatu siddhidam uttarottaram bhavatu siddhidam.
Thank you, sir. I now request Srimati A.P. Beena, Vice Chairperson of AESI Trivandrum Chapter, to kindly welcome the gathering.
Most respected Chief Guest of the day, Dr. Satish Reddy, Chairman DRDO and Secretary, Department of Defense Research and Development, Sri S. Somnath, Director VSSC, Dr. V. Narayanan, Director LPSC, Dr. Sam Dayala Dev, Chairman Aeronautical Society of India, Thiruvananthapuram and Director IISU, Dr. L. Mohan Kumar, Honorary Secretary of AESI Thiruvananthapuram, distinguished invitees and fellow AESI members. First of all, let me join Sri Arun Raj in wishing and praying for the new year to bring in good health, prosperity and success to all. We are gathered here today for the 21st Dr. Srinivasan Memorial Lecture organized by the Aeronautical Society of India Thiruvananthapuram branch in association with Vikram Sarabhai Space Center, which in line with the current protocols is being conducted online. Dr. Srinivasan, the former director of VSSC, was one among the pioneers who was instrumental in making India self-reliant in launch vehicle design, development and launch vehicle operations. An exemplary leader, a visionary, a technocrat, an efficient manager and an institution builder, he was also well known for his humane and down-to-earth nature. A memorial lecture in the name of Dr. Srinivasan is one of the flagship programs of the Aeronautical Society of India, Thiruvananthapuram, being conducted since the year 2000 to honor this great visionary, to cherish the fond memories and also to carry forward his legacy. These lectures, delivered by stalwarts in the field of aeronautics and aerospace, focus on topics that are futuristic and are most relevant to the aerospace community. For the 21st Dr. Srinivasan Memorial Lecture today, we are extremely fortunate to have with us Dr. Satish Reddy, the Dynamic Chief of DRDO and Scientific Advisor to Raksha Mantri, who has been instrumental in making the country attain self-sufficiency in missile technology and also in initiating many new projects to equip our armed forces with state-of-the-art weapons and technologies. A globally renowned navigation expert, he has risen to a leadership position at a very young age and has led many labs of the DRDO like the ASL, the DRDL, RCI, ITR, TBRL and other technical facilities. His technological contributions have left a lasting imprint on the technology map as well as the defense preparedness of the country, and needless to say, highly deserving laurels have come his way. For Aeronautical Society of India, it is all the more heartening that we have a very active member of the Aeronautical Society delivering this prestigious lecture here today. The ASI Hyderabad branch under his chairmanship has been bustling with activities, bagging the Best Branch Award. Despite his busy commitments, he has readily accepted our invitation and has kindly consented to be with us online today. I feel honored to welcome Dr. Satish Reddy to this function to deliver his lecture on Aeronautical Ecosystem in India. A warm welcome to you, sir, on behalf of Aeronautical Society of India and on my personal behalf. The topic has generated great interest and we are really eager to hear from you, sir. Sri S. Somnath, Director VSSC, is an exemplary space technologist and a great leader. He always takes special interest in ASI activities and has been offering his valuable suggestions and advice for the conduct of this event. A person who stepped into this organization reporting to Dr. Srinivasan and has been groomed to perfection under his mentoring, Sri Somnath reflects many good qualities of Dr. Srinivasan. He has been kind enough to offer his felicitations for this event. On behalf of ASI and on my personal behalf, I have great pleasure in welcoming you, sir, to this event. Dr. V. Narayanan, Director LPSC, is a propulsion expert who was instrumental in the development of C-25 cryogenic stage, which played a vital role in the successful launch of GSLV Mark III vehicle. The semi-cryo technology, which is crucial for the next generation heavy lift vehicles, has matured under his leadership. He has always been closely associating with and supporting ASI activities. Let me extend a hearty welcome to you, sir. Dr. Sam Dev, Chairman ASI Thiruvananthapuram branch and Director IASU, is an efficient technocrat with a futuristic perspective and is an expert in the area of navigation systems. As Chairman ASI, he has been a tremendous source of support for the organizing of this event, and he will also be presiding over the function. On behalf of ASI family, let me extend a warm welcome to you, sir. I would also like to extend a warm welcome to Sri S. Pandian, National Vice President ASI and all former Chairman ASI Thiruvananthapuram branch for this event. Let me also welcome Dr. L. Mohan Kumar, Honorary Secretary, and Sri K. S. Nandakumar, Honorary Treasurer of ASI Thiruvananthapuram branch, who were instrumental in meticulously organizing this online event. A function like this is made successful by the overwhelming participation from the Management Council members of ISRO centers, senior colleagues and fellow ASI members. Let me heartily welcome you all for this function. Once again, welcome you all for this 21st Dr. Srinivasan Memorial Lecture. Thank you and Jai Hind.
Thank you, ma'am. Dr. Sam Dev, Director, ISRO Inertial Systems Unit and Chairperson, Aeronautical Society of India, Trivandrum, is a connoisseur in the design and development of autonomous navigation systems with ultra-stable inertial sensors, advanced actuators, and robots. An efficient technocrat and a proficient leader, he continues to lead the organization in the march towards new frontiers. I now request, sir, to kindly deliver the presidential address.
Most respected Dr. G. Satish Reddy, Secretary, Department of Defense R&D, Shri S. Somnath, Director, VSSC, Dr. V. Narayanan, Director, LPAC, Srimati A.P. Beena, Vice Chairperson, Aeronautical Society of India, Trivandrum Branch, Dr. L. Mohanakumar, Honorable Secretary, Aeronautical Society of India, Trivandrum Branch, dear friends, members of AASI, ladies and gentlemen, New Year greetings to all of you. Let this New Year be a great blessing and full of activities for the aeronautical engineers. Let me also welcome you all for the 21st Dr. Srinivasan Memorial Lecture held today on online platform. One of the primary goals of AESI is information dissemination or sharing the fellow aeronautical professionals and educating and enlightening the youth and students of this country, primarily to kindle the enthusiasm and excitement with science in general and aeronautics in particular. Dr. Srinivasan, who is the architect of operational launch vehicles in Indian space sector and a fine aeronautical engineer himself, is one such personality who is eager to share information with colleagues and all the more with younger and junior colleagues. I fondly recall my association, or I would call it my encounter with Dr. Srinivasan some 34 years back, when he patiently enlightened me on the flexibility of or free modes of vibration of a launch vehicle, then a novice and a fresh engineer. So now, you know, we are also actively involved with our red gyroscopes to control or manage these flexible modes. In fact, every year we recall and rather we celebrate his contribution with the memorial lecture. The earlier speakers in this forum had been personalities who have contributed to the aeronautical ecosystem in this country. Today, I am extremely happy that the 21st Dr. Srinivasan Memorial Lecture is to be delivered by Dr. G. Satish Reddy, who is the doyen of all sort of aerial vehicles and in this country, and specifically on the navigation and guidance and control of these vehicles. Moreover, he is a former director of RCA, and under his leadership, innovative developments materialized in inertial sensors area. You know, RCA and IASU dominate the Indian inertial sensors and navigation technology domain and the sat-nav applications. Being a very dynamic personality, it is very difficult to get Dr. Reddy for such lectures. However, the COVID pandemic has been a blessing in disguise. For the 21st Memorial online lecture, we could have Dr. G. Satish Reddy as chief guest and speaker. All the more excited to hear him talk on the aeronautical ecosystem in India. As I mentioned earlier, Aeronautical Society of India is promoting the knowledge dissemination to ensure that the youth are attracted to science and aerospace or space sector. So far, we had been only highlighting the challenges and the success stories of how challenges are overcome, thereby attracting younger minds and fellow professionals. Now I feel it is time for the aerospace community to get support from non-aeronautical experts too. The in things these days is to time to market or time to success. Success alone is no more exciting or acknowledged if it is delayed or extended. Shortening the time to achieve the technology goals is a major challenge we face today because of the economics involved as well as the competition that is involved. Days have gone when projects stretch for 10 to 15 years to fructify. Now major projects are to be conceived, defined, technology developed and qualified and operationalized within 2 or 3 years. Otherwise, another innovator walks away with the cake. This is what we are seeing internationally. No more we have the luxury of time. Space sector is dodged by the known unknowns and unknown unknowns, as you all are very familiar with. The unusual long time for development of launch vehicle or missiles are primarily due to our efforts to minimize the unknown unknowns to ensure enhance the reliability. If we need to shorten the development time and these unknown unknowns are to be eliminated, what is the way out is cross-domain information flow. For example, in our country globally, great innovations are happening in application of artificial intelligence and machine learning techniques. We don't need to reinvent the wheel in these areas. How to make such experts also complement the aeronautical engineers in making things happen at a faster rate. Then these challenges are to be communicated to such experts in these fields to reap the benefits of the fast developing data science engineering. Aeronautical Society of India is primarily sharing the information to aerospace community only, other than of course students community. Now it is really important to extract the intelligence, within quote I will mention, hidden on the unknown unknowns or hidden unknown unknowns from the enormous data these organizations like DRDO or ISRO have. I feel we should enable synergy of wider spectrum of professionals, thereby enabling shorter development cycles. Therefore, there should be an instrument, the Aeronautical Society of India should be an instrument for cross sharing of such opportunities to other professionals, and a data science expert or science expert can also become an aeronautical professional by this way. Once in an international conference, I met some delegates who were basically communication experts who got involved in SatNav application by virtue of that technology, and soon were rubbing shoulders with inertial navigation experts and turned into inertial sensor technologists presenting paper on inertial sensors. So this sort of cross or hybrid of various domains definitely help in shortening the development cycle or the time to success. Therefore, Aeronautical Society of India also should become an enabler of cross-domain expertise demands or information for information exchange. Well, as we are eagerly waiting for lecture on aeronautical ecosystem in India from the horse mouth, I challenge the ASI members to ponder how our society can enable cross-pollination of domain expertise to enable faster turnaround in aerospace developments. Thank you. Jai Hind.
Thank you, sir. Shri S. Somnath, Director, Vikram Sarabhai Space Center, is a leading authority in the field of launch vehicle technology. He is widely known for his expansive technical expertise and his inspiring multifaceted personality. Under his exceptional leadership, the organization continues to scale new heights every single day. I now request Sir to kindly offer his felicitations.
Honorable Chairman of Aeronautical Society of India, Dr. Samdayala Dev, Director of LPSC, Dr. Narayanan, Vice Chairperson of the Aeronautical Society of India, Srimati Beena, Secretary Sri Mohan Kumar, and all the distinguished participants for this program, fellows of Aeronautical Society of India, members. My greetings to you on the occasion of the 21st Dr. Srinivasan Memorial Lecture Series being delivered today by Dr. Satish Reddy, Secretary, as well as Chairman DRDO. This is an occasion we remember the contributions of Dr. S. Srinivasan, the designer of rocket systems in VSSC, and also commemorate the successes that we have made in the launch vehicle scenario while we listen to great people on the contributions of Dr. Srinivasan as well as the future directions in the area of high technology of rocket systems as well as space science. Today we have Dr. Satish Reddy going to deliver this talk, and we are really honored to have Dr. Reddy for this program. Dr. Srinivasan is a Karmayogi who have contributed immensely to the development of rocket technology in this Indian Space Research Organization, starting with service at SSTC, later moving on to the SLV3 program, being the second in command in the SLV3 program, contributed immensely for the development of the SLV3 vehicle. Then later moved on to the PSLV project as his project director, first project director, establishing the architecture of the PSLV and as well as building up the facilities and infrastructure to such an extent that he handed over the mantle of the project to Dr. Madhavanaya, later for his successful accomplishment in the PSLV's D2. During those times, I, being a young engineer in PSLV project, had the opportunity to see Dr. Srinivasan in action in various fronts, right? As the project director of the PSLV, giving shape to many of those critical decisions in the architecture of the PSLV, as well as management of the project and establishing the project organizational structure to its smooth flow, as we see today in various programs of ISRO. The establishment of the facilities all across this country in realizing various hardwares, establishing the test facilities in ISRO centers as well as in industry and academia has been one of his greatest accomplishments. And later, after he moved over from PSLV project to the Integrated Launch Vehicle Program and also was director of SDSC and later director of VSSC, he has been such a nice, gentle person who has been helping and mentoring people like me and many others to undertake greater amount of studies, looking at architecture of launch vehicles and then improving them and helping us to learn and become masters in the field that we have chosen today. I also remember him when I had the opportunity to chair the first MRR of the PSLV recently. I remember Dr. Srinivasan chairing the FRR launch vehicle program of PSLV before the first launches. Those times were so critical and those so active. The type of challenges and issues that were brought in front of him and how he handled them to a solution, amicable solution to take the launch vehicle forward is really amazing. And I'm really honored and bowed before him, his memories, for those learning that he has imparted to our generation so that we are able to take forward the work of designing, developing future launch vehicles and also take the success stories forward. Dr. Srinivasan, in my personal experience, was such a gentle person, but never pardoning small, even silly mistakes. His ability to review and comment on our documents are well known, and really punishing for those people who really make mistakes or do not care about it. So he was such a perfectionist and a workaholic that somehow we start imbibing those characteristics and nature in the work culture of our organization, which is really bringing benefits and fruits for our program to succeed. Today, we also have a great person, legendary person, Dr. Satish Reddy, chairman of DRDO, delivering this Dr. Srinivasan Memorial Lecture today. As we all know, he is such a visionary person and a leader in DRDO who has an ability to transform the organization from the earlier years of the successes that has obtained in the missile development program and various other areas to a newer height where the real Atmanirbharta that we have looking for in the defense sector, in the area of defense research, production of armaments and supply systems for the defense forces, and become one of the important contributor for this mega area where a lot of challenges are lying ahead, especially the user being our armed forces and that those who are working for the security of the nation are looking forward for Indian origin systems for supporting the security of our nation is being addressed by him in such a manner that success in the recent times are really talking about the ability of DRDO to transform from the sleeping organization to a very active organization, if I must say. The challenges in DRDO has been handled by him is really enormous. I had an opportunity recently to understand and interact in these matters with the support of Dr. Reddy, and really it has been an eye-opener for a person like me to realize the length and breadth of the organization and the challenges that they are facing far beyond the rocketry that we are talking about here. I wish all the best to Dr. Reddy for his success and also for greater accomplishment in the future. And we also look forward for his talk today. I'm sure it will really benefit the community of aerospace engineers who are working in Trivandrum, as well as this opportunity that is given today in the form of this lecture being delivered in the this web media enables a larger audience of the aeronautical community, and I am sure it will benefit all across this country to listen to his words and then being inspired. Let me take this opportunity to congratulate the Aeronautical Society of India for organizing this talk year after year and bringing stalwarts on the platform to speak about Dr. Srinivasan and also the growth of this sector, which is very, very important. And this is the time when the Aeronautical Society has to take a greater role in bringing people together from different sectors of aeronautics especially in the area of rocketry, missiles, aircraft development, and also associated systems like spacecrafts, ground infrastructure, and generally that we are looking forward the self-reliance in this sector and greater association of the entire aeronautical field to build up a stronger nation. I think this vision of the government needs to be supported, and I am sure many of the people in the Aeronautical Society of India can work together to generate a vision document that will help the entire country to move forward and to be guided by, help in guiding the country and the government towards this direction. I wish all the best to the Aeronautical Society of India and the leadership of the Aeronautical Society of India for taking this activity forward and organizing this lecture specifically. And thank you for the opportunity and wish you all the best.
Thank you, sir. Dr. V. Narayanan, Director, Liquid Propulsion Systems Center, is a doyen in the domain of liquid propulsion systems. Widely known for his role in the development of cryogenic systems, his leadership and extraordinary contributions continue to fuel the advancement of the Indian space program. I now request Sir to kindly offer his felicitations.
Dr. Samdayal Dev, Director IASU and Chairman Aeronautical Society of India, Thiruvananthapuram branch. Somnath Sir, Director VSSC. Our Chief Guest, Dr. Sadish Reddy, Chairman DRDO and Secretary Department of Defense R&D. Dr. Mohana Kumar, Honorable Secretary AESI Thiruvananthapuram branch. Members of Aeronautical Society of India and friends. Very good evening to all of you. First of all, let me join with all of you in welcoming Dr. Sadish Reddy, who is delivering the Dr. Srinivasan's 21st Memorial Lecture on Aeronautical Ecosystems in India. I feel this is a very, very apt and befitting topic for this occasion. I feel really privileged to be here to share some of my experiences with our most respectable and beloved Dr. Srinivasan sir. You all will agree with me, he is a multifaceted and multi-talented rocket scientist, contributed immensely for our space program. He was the Deputy Project Director of SLV-3, working hand in hand with the Project Director, our People President APJ Abdul Kalam, and brought glory to India. He was the Project Director of the PSLV project in the initial phase. He was also the Program Director of the Integrated Launch Vehicle Program. He has served as the Director of SHAR and Director of VSSC. He had major contribution in the overall configuration and realization of the PSLV and the configuration design of the GSLV Mark II vehicle. You know, he was an institution builder. The PSLV facilities at Valiamala was totally his brainchild, and it was built totally by him. He was also a person responsible for conceiving and bringing up the structural test facility, what we call it as the INSTA facility today. And he is a person always encouraging the working of youngsters, and he has always encouraged the indigenous development. Above all his technical contribution, he was a soft-spoken, kind-hearted, gentle, and a great human being. He is a person who always prepares himself before any meetings. I want to share one of my experience. During the ASLV D2 time, he was the FRR chairman. You know, I happened to attend a couple of meetings as a very, very young engineer that time. He used to take all the papers home, prepare thoroughly, and come and chair the meeting. And today, I think Somnath sir and other people have very nicely elaborated his contribution. I thought I will share some of my experiences in his major contribution in the area of propulsion system development, that too specifically cryogenic propulsion system development. It was in 1991 we signed a contract with Cosmos, then Russia, for the cryogenic stage delivery and the technology acquisition from GK. And there was a 5-member committee who was given the responsibility to select the team for the technology acquisition, and he was one among them under the leadership of Dr. A.E. Muthanayagam. I was fortunate enough to be selected by this committee to participate in the technology acquisition. And before this contract was entered, originally for the GSLV Mark II vehicle, LPSC was entrusted the responsibility of the development of an indigenous C-12 cryogenic engine and associated the stage systems. Towards that, a 1-ton class thrust chamber and a 12-ton class thrust chambers were realized, and it was put through the test program. The first 1-ton engine was put through the test somewhere in 1993, and we made the first attempt to test the chamber with liquid oxygen and liquid hydrogen. And unfortunately, immediately after authorizing the test, we ended up with a failure. And an inter-center committee was constituted to understand the reason for the failure and to recommend the required improvements and modifications to overcome the problem. And the committee was chaired by none other than Dr. Srinivasan sir, and the committee did meticulous job under his leadership. Finally, based on the recommendation, we did enough improvements, necessary modification in the facility side, necessary modification in the test sequence. Finally, to our credit, today we have successfully completed 10 hot firings of the second hardware, including a 200-second test. Then comes to the C-12 thrust chamber. C-12 thrust chamber, it was designed for delivering a 12-ton type of thrust in vacuum level. So in the sea level, due to the facility limitation, we can test to a level of almost 1/3 of the thrust. And when we attempted the hydrogen flow trial, to our surprise, there was a big flame in front of the chamber when the hydrogen came out of the chamber. Then there was really a worry whether to authorize the test or not. Then Chairman Dr. Kasturangan sir appointed a single-man committee with Dr. Srinivasan sir as the chairman. And as a design team member, we were really thinking whether he will authorize the test or not. Finally, after detailed discussion, he was fully convinced and he authorized the test. And today, it is a history. We did 2 successful tests in the C-12 thrust chamber. I feel the entire credit goes to Dr. Srinivasan sir for his review and final recommendation to Chairman ISRO. But for him, this test would not have happened. Now, if you see, these 2 R&D activities has fed the full data to the indigenous development of CE-20 engine of the Mark III program. And today, Mark III C-20 engine is a very successful story, and we have successfully completed, and in the maiden attempt itself in the GSLV Mark III D1 flight, the C-25 stage performed extremely well, and really Dr. Srinivasan sir hand is there in that program. And if you see the test facilities for the cryogenic program in IPRC under the CUS program, the entire requirement of the test facility was reviewed by Dr. Srinivasan sir committee. And today, if you go to IPRC, all the facilities will speak about him. And on this occasion, I salute him for his contribution towards the entire space program, for the vehicles he has contributed, and specifically I want to salute him for his wonderful contribution for the indigenous cryogenic propulsion system development. He is a person who was always bringing up the next generation. One thing I would like to share, it was 1999. There was a ISRO Space Generation Task Group was constituted, and there were 50 members selected across the ISRO centers. I remember our Somnath sir was there, and I happened to be there as one of the members. It was through that program only, really, we got a feel of the entire ISRO activities. Today, most of that 50 members, they are occupying very senior roles and contributing for the program. Dr. Srinivasan sir is a very, very simple person. I still remember, it was in 1992. I was going to IIT Kharagpur for my PhD work, traveling from Trivandrum to IIT Kharagpur by train, second class. And he, along with his family, was also traveling in the same compartment up to Chennai. And it was a great time. I was only in the SD grade. And almost 3 to 4 hours, I had the opportunity to discuss with him. He was showing so much interest on the indigenous cryogenic development and my PhD work, how it is going to feed for the indigenous cryo development. And it was really a great day for me, spending almost 3 to 4 hours with that great person in the second class train. And the nation has very aptly honored him with Padma Bhushan Award in the year 2000. It is really quite unfortunate that a man of his ability and stature could not complete his service period following his untimely death at the age of just 58. And I feel it is a great loss to the entire aerospace community, and we would have got great benefit, great contribution from this great person, Dr. Srinivasan sir. Hence, on this occasion, let us rededicate ourselves to carry the legacy of the great stalwart, Dr. Srinivasan, and take the baton forward to enhance our nation building commitments to greater and greater heights. Let me thank ASI for giving me this great opportunity to share some of my experiences. I am very keen to hear the talk of our chief guest, Dr. Sadish Reddy, who is a veteran in aerospace field, on the topic Aeronautical Ecosystems in India. Thank you. Jai Hind.
Thank you, sir. I now request Shri K.S. Nandakumar, Honorary Treasurer, AESI Trivandrum, to kindly introduce the speaker for today's function.
Ladies and gentlemen, Dr. G. Sadish Reddy doesn't need any introduction to Aeronautical Committee in India. As a customary practice, I would like to mention his contribution in building a coherent, dynamic aerospace ecosystem in India. Dr. Sadish Reddy is well known for his significant contribution towards indigenous design, development, deployment of diverse missiles and strategic systems, guided weapons, avionics technologies, and sustained efforts in advancement of aerospace technologies and industries in India. He joined DRDL Hyderabad in the year 1986 and subsequently joined Research Center Imarat. From a young navigation scientist and system manager, he rose steadily, and after his multiple significant appointments and decades of sustained contribution to defense R&D, was elevated as distinguished scientist in September 2014 and was appointed as scientific advisor to Defense Minister in May 2015. He significantly contributed towards formulation of many national policies and was pivotal in evolving roadmap for self-sufficiency in missiles. As the Director General Missiles and Strategy System, he spearheaded Dr. APJ Abdul Kalam Missile Complex Laboratories. He invigorated the ballistic missile defense program and developed the mission critical technologies for long-range Agni-5 missile. As Director RCI, he led many programs, projects, and steered the development of indigenous RF and IIR seekers. is a renowned navigation expert and as a project director and technology director, steered the design and development of indigenous inertial sensors, sat-nav receivers, advanced inertial navigation system for a variety of defense applications. He is a fellow of Royal Institute of Navigation, London, Royal Aeronautical Society, UK, and a foreign member of Academy of Navigation and Motion Control, Russia. He is also an honorary fellow of Computer Society of India, Project Management Association of India, fellow of Indian National Academy of Engineering, associate fellow of American Institute of Aeronautics and Astronautics, and many other academies and scientific bodies in the country and abroad. Dr. Satish Reddy has received several prestigious international and national awards, which includes Homi J. Baba Gold Medal, the first IEI IEEE USA Joint Award for Engineering Excellence, Silver Medal of Royal Aeronautical Society of London. He is also a recipient of Dr. Biren Roy Space Science Design Award, Astronautical Society of India Rocketry and Related Technologies Award, and National Aeronautical Prize. Dr. Satish Reddy has long association with Aeronautical Society of India. He is currently the chairman of Aeronautical Society of India Hyderabad branch, which under his tenure become one of the vibrant branches of Aeronautical Society. Let me welcome Dr. Satish Reddy for delivering the 21st Dr. Srinivasan Memorial Lecture.
Namaskar, Dr. Shyam Dayal, Director IISU and Chairman Aeronautical Society of India, Thiruvananthapuram branch, Sri Mohanlal, Honorary Secretary, and all the people who are present in this meet. Once again, Namaskar, and my sincere thanks to Dr. Shyam Dayal for inviting me to give 21st Dr. Srinivasan's Memorial Lecture here. I congratulate Aeronautical Society of India Thiruvananthapuram branch and VSSC ISRO for organizing this event. Talking about the topic of my address, the aeronautical ecosystem in the country. I have structured the talk like this: the evolution of aeronautics in India, the current status of whether it is fighter aircraft programs and helicopters and transport aircraft, UAVs, and the future system, the ecosystem, what has come up and what is going to come up, and concluding remarks. When you look at the evolution of aeronautics in the country, the first commercial flying in India took place from Allahabad to Niani on 18 February 1911. And then Tata Sons started airmail service with Tata Airlines. Later, about 9 air transport companies have emerged in the country, and all these in 1953 have been nationalized and merged into Indian Airlines and Air India. On 8th October 1932, Indian Air Force came into existence with one after another the squadrons formation in the country, and even fought the World War II, and has been supporting many aircraft development in the country. If you look at the establishment of industries in the country, Hindustan Aircraft Limited was established in 1948 Bangalore by Sri Walchand Irachan. 1951, HT-2 trainer aircraft was designed and produced by the company. In 1963, Aeronautics India Limited was established as government-owned company for licensed production of MiG-21. And the two companies were amalgamated on 1st October 1964 by Government of India and named it as Hindustan Aeronautics Limited which is the present HAL. And HAL started producing various aircrafts, HF-24, HJT-16, Kiran, MiG-21s, then Jaguars and Sukhoi 30, Hawk, Dornier aircrafts, and many other things. Friends, let me tell you here, the HF-24 aircraft, the fighter aircraft, Marut, which is produced in the country, is the first fighter aircraft designed and developed in Asia outside USSR. It has participated in the wars and never the HF-24 aircraft was shot down. So we are the first fighter aircraft development which took place in this country in the entire Asia. And when you look at the roadmap, these are all the various aircrafts and systems which have been developed in the country, and finally the emergence of light combat aircraft TEJAS. When you look at the LCA development in the country, in the 1980s, it was thought that we should develop an aircraft, fighter aircraft in our country. And then some studies on that started, and some design aspects, looking at the specifications, evolving the specifications, and then development of some of the technologies, and finally taking up a program to develop the light combat aircraft, which actually resulted in technology development, various aircrafts, and finally in January 2001, the first TD-1 flight took off. It's a remarkable event for the country, developing the indigenous fighter aircraft and taking off and landing, and then onwards number of trials started happening. And in year 2013, the initial operation clearance is obtained, and in the year 2019, the final operation clearance has come, and the aircraft started producing the IOC configuration, the FOC configuration, and there onwards getting into now LCA Mk1A. Looking at the various technologies and systems in the country, coming to the number of aircrafts, totally 4,155 aircrafts have been produced in the country, and some of them are indigenous design, some of them are licensed production. Similarly, number of engines, more than about 5,000 engines have been produced in the country, and most of them are under licensed production. Engine is still one which need to be produced in the country, which actually really put into aircraft and flying it. And I think that dream should be coming soon, making our own engine and flying in aircraft. Coming to the helicopters, in 1970, the Cheetah helicopter started producing under license production here in the country. Then the indigenous helicopters started coming in, whether it is the ALH, Advanced Light Helicopter, or the Light Combat Helicopter LCH, and then Light Utility Helicopter LUH. So many helicopters, one after other, started coming, inducted into the armed forces. And if you look at the exports, these are all the exports from this country which have been sold to various other countries from Hindustan Aeronautics Limited. And then some of the repair and overall facilities have been established both for fixed and rotary wings, which are depicted here, whether it's Su-30 or MiG variant, Jaguar, Mirage, and many other aircrafts. Coming to the transport and civil aviation in India, some few aircrafts have been developed in the country, like AMCA NG, which was developed by CSIR, the NAL, National Aeronautics, National Aerospace Laboratories, NAL. And the Saras aircraft, the 19-seater, is under development. And also, there have been a strong proposal for developing the RTA within the country. I'm sure in the coming years, we should be able to come out with our own RTA, and there are many steps the government of India is taking towards building the aviation in the country, whether the infrastructure, the runways at small towns and cities, and the necessary ATC air traffic control infrastructures, and of course the aircrafts, are all the things are taken into consideration, and I think the country will be taking a big leap in this direction. Then the unmanned aerial vehicles, number of systems have been developed in the country. The Aeronautical Development Establishment of DRDO at Bangalore developed the Lakshya PTA, the pilotless target aircraft, which has been used for number of missiles and other things testing application. The Abhyas, another expendable aerial target, which has been developed, and number of mini and micro UAVs which have been developed, which are depicted here. And then the Nishant, the Panchi UAVs, which again have been used extensively for various applications, including surveillance. The Rustum 1 and Rustum 2, which is flying now. I'm sure that very soon Rustum will be able to achieve its goals of 24 hours endurance and close to 30,000 feet altitude, along with its payload, which becomes one of its class male, medium altitude long endurance UAV. And then we have also developed ourselves in the country AWC systems, advanced early warning and control systems, and systems have been developed, inducted into the armed forces, building on the aircraft, Embraer aircraft, and have been inducted into the Indian Air Force, and which has been continuously used by Indian Air Force, and which has paved the way for coming out with many more in the future, the VAC systems built within the country. And when you look at the developments which are now taking place and going to take place, as I said, from HF-24 Marut and 2001 when the LCA took off, not only the LCA took off, the number of technologies, fourth generation technologies have also been developed, and they also have flown with the aircraft. So many technological developments started happening in the country. The ecosystem started building in the country. With the LCA, lots of industries started working on many technologies. And as you see this here today, the roadmap, LCA Mk1, LCA Mk1A, LCA Mk2, the AMCA Mk1, the AMCA Mk2, and then the naval aircrafts is the clear roadmap what we have today. Right from 4th generation light combat aircraft to TEJAS MK2, which is advanced version, which is a medium weight, and then the 5.5 generation stealth aircraft, advanced and medium combat aircraft AMCA. These are the roadmap where the design work is very seriously going on, and the twin engine deck based fighter aircraft for the Navy as another aircraft. So lots of critical technologies have been developed, are being developed. The aero models, the control laws, the flyby flight control, the composite structures, the stealth materials, and the advanced avionics, test facilities, infrastructure, manufacturing capabilities. Many things have come in the country, and there are more than about 120 industries which are actually producing a Tier 1, Tier 2 industries. And then at the component level, there are more than 400, 500 industries which are producing for these aircraft today in the country. There are many academic institutes which are working in the country, developing many technologies, carrying out research in the area, coming out many algorithms, many new systems and technologies which are required for the development of these advanced aircrafts. And as you know, for the LCA, the first pattern was formed in 2016, and the IOC standard aircrafts have been produced. The FOC standard aircrafts are under production now, and soon the LCA Mk1A will start getting produced. This is the LCA Mk1A configuration, wherein you have active electronic scanning array radar, which is indigenously being developed now, the electronic warfare suite with external SPG part, and then many missiles and maintainability improvements and system improvements which have been incorporated, and that's the configuration of LCA Mk1A which will be produced and which will get an approval very soon from the Government of India. And looking at LCA Navy, last year, it's a momentous occasion where the LCA has landed on Vikram and then took off. A number of takeoffs and landings have happened, paving the way for a development of naval fighter aircraft. Looking at the LCA Mk2, the configuration is given, which will be a replacement for an advanced version of Mirage and Jaguar aircrafts with lots of features including OBACs, onboard oxygen generation system, indigenous missiles like Astra and SA, and many other missiles and bombs which are developing in the country, having about 6,500 kg of weapon capability. And the PDR is completed and many of the systems are getting realized now. And the system is in advanced stage. I am sure that in the year 2022, this aircraft will be rolled out. And the advanced and medium combat aircraft, which is a 5+ generation aircraft having the stealth features, design studies have been completed, configurations are frozen, PSCs are released by the Indian Air Force, and the PDRs have completed, and work is going on very seriously in this aircraft. And in both the aircraft's manufacturing, HAL and industries are participating in a big way. And the next one is the twin engine deck based fighter aircraft for the Indian Navy, replacement of MiG-29K and with many modern features. With all these development going on and development moving forward, looking at the ecosystem in the country, as I said, firstly talking about academia, with very few academic institutes and very few professors working in this area. Today, I can say there are more than 100 academic institutes are working in this area today. There are many professors working on varieties of problems today. We are able to get lots of basic research and applied research outputs from the academic institutes. We are able to give lots of projects for these aircraft which we are developing right now for the design of varieties of algorithms, systems development, configuration studies, and whatnot, many things. We have now probably in the country hundreds of researchers working on this area. The many industries which have come up, as I was telling you, there are more than 500 industries working for the aircraft development in the country, whether it is in the development as built to print or built to specifications also, developing a lot of software and producing them in numbers and trying to supply in the supply chain requirement of the aircraft manufacturing production. In fact, today the country has become the aircraft manufacturing hub. Many giant airline manufacturers in the world are having the supply chain from India today. Lots of industries are supplying various parts of the aircrafts, helicopters from India and supplying to all those big companies outside like Airbus, Boeing and whatnot. And in fact, even aircrafts are also getting manufactured in the country like Falcon, and probably soon are many other aircrafts also in the country, even in the RTAs and related activities also. And so this ecosystem is the one which is very important for any country in the development of aircrafts within the country with the indigenous capabilities. As I said, when you say indigenous capabilities, right from the configuration studies, the design of the aircraft, the aero models, the aero studies, and then the control laws, the various subsystems and LRUs, avionics, and many things development in the country, right from the smallest possible nut and bolt to the high-end systems like inertial navigation systems and control actuation systems and hydraulic systems, landing gears, many things. They're all being developed in the country. Many of those things are designed and developed by various R&D organizations, DRDO, ADA, and many other people, NAL, and then getting produced at various DPSUs, HL, Bharat Electronics Limited, or BHEL, BEML, and then number of private industries which are working. I'm sure that in the coming years, the private industries will be playing a major role. If you look at the major work centers, these are all the work centers which are spread across in the country in the TEJAS ecosystem in a big way. And these are all actually, as I said, which are the system level suppliers and so on and so forth and academic institutes. And there are many industries which are there at the next levels, which are supplying at the component levels and other things. And when you look at the future, India once develops LCA Mk2 and AMCA systems, India will be emerging as the front runner in the aircraft development, advanced aircraft development, and attains the capability to develop any type of aircraft system in the country. With the private industry coming in a big way, we will be able to export these aircrafts and helicopters in a big way to the entire world. I'm sure the Indian cost will be much less compared to any other system outside. And this makes the country really prosperous. And then there's a lot of work what the country needs to be doing is in the current area of drones, UAVs, tails, mails. This is one area where we need to concentrate, along with the varieties of sensors which are required on that systems. And even the world, if you look at the war, what has happened with Azerbaijan and others, where the weapons on these drones and UAVs have played a major role. That is another area, which is actually upcoming area we need to concentrate. And many things they're talking about today, mini drones, swarms, swarm control, and weapons delivery through them, and with lots of artificial intelligence built into it, and the secure communication what you need to have among them and from the control stations. These are all the areas which actually today we need to concentrate. And if we are able to work in these advanced areas, we are able to come out with innovative ideas, and we are able to come out with innovative manufacturing technologies and many materials development which are required for the aircraft industry today. I'm sure that we will be the leaders in this field. I'm sure that is not very far. End of this decade, I'm sure we should be able to realize this dream. We will be world leaders, supplying our aircrafts, aeronautics, avionics, everything to the entire world, making this country proud and prosperous. Thank you for giving me this opportunity. Namaskar, Jai Hind.
Thank you, sir, for your enlightening words. I now request Dr. L. Mohan Kumar, Honorary Secretary, AESI Trivandrum, to kindly deliver the vote of thanks.
Chief guest of today's program, Dr. G. Sadish Reddy, Chairman DRDO and Secretary, Department of Defense R&D, Government of India. Director, Vikram Sarabhai Space Center, Sri S. Somnath. Dr. V. Narayanan, Director, Liquid Propulsion System Center. Dr. Sam Dev, Director, ISRO Inertial Systems Unit, and the Chairman of Aeronautical Society of India, Trivandrum Branch. My dear fellow Aeronautical Society members and dear invitees. Dr. Srinivasan Memorial Lecture is one of the most important annual events the Trivandrum branch of the Aeronautical Society of India is conducting every year. This year, because of the restrictions imposed by the COVID-19 pandemic, there has been a slight delay in this function, which we generally conduct in August every year. But today, we deem it extremely fortunate to have Dr. Sadish Reddy, an eminent personality with international fame, to be with us and to speak to us and deliver the Dr. Srinivasan Memorial Lecture. Today, Dr. Reddy has actually delivered an excellent, informative, and an exciting lecture. And on behalf of the Aeronautical Society of India, Trivandrum branch, I place on record our sense of gratitude to you, sir. Thank you very much, sir. Sri S. Somnath, Director, VSSC, has been always actively involved in the activities of our society. And of late, he has been a mentor in organizing all our conferences and outreach programs. We would like to thank you, sir, for your presence and the felicitation address today. Dr. Narayanan, Director, LPSC, has been a pillar of support for all the activities of our society and has been keenly following all our programs. We would like to thank you sincerely for your felicitation address today. Dr. Sam Dev, the chairman of our Trivandrum branch of Aeronautical Society of India and Director IASU, has been the motivational force behind all our programs of this branch in the current executive committee. He has been meticulously following up all the programs which have been conducted this year and has been ably guiding us through these ventures. We would like to thank you, sir, for your presidential address as well as for all your guidance and support. This program has been the success of a lot of executive committee members' collective efforts, and I would like to thank all of them sincerely. And special mention to our Vice Chairperson, Srimati A.P. Bina, for her welcome address, and Sri Nandakumar for introducing the speaker. And I would like to thank all the members who have participated in this lecture and made it a success. Last but definitely not the least, I would like to thank the TTDG group of VSSC for their able support and guidance in planning this program online and to make it in the way which we saw just now. Thank you all of you for making this program a success. Thank you and Jai Hind.
Thank you, sir. With this, we come to an end of today's function. Let us conclude with the resolve of carrying Dr. Srinivasan's legacy into the future, and with the hope that activities of the Aeronautical Society of India continue to motivate and inspire society. Thank you all. Jai Hind.